Hello and welcome to this video in which I will show you how you can specify a confirmatory factor analysis or structural equation model for free without syntax using the lavaangui. My name is Geiser, I'm an instructor with QuantFish. So let's get started. A very nice way to set up a confirmatory factor analysis or SEM quickly without having to write code is to draw a path diagram. And there's a guide now available for the lavaan package in R that does exactly that. It allows you to generate lavaan syntax from a path diagram and also gives you pretty much all the relevant output that you would want for such a model. And the great news is you don't even have to install lavaan or know lavaan or have knowledge of the R statistical software that is the environment for the lavaan package. It all works online. So all you need to do is open your browser and then type in lavaangui.org. And that takes you to a website where you can do all the things that you need to do, beginning with importing your data file. So let's do that. And so when we click on File, Load Data, we can open our data set. And the nice thing is that the lavaangui allows you to work with different file types. As you can see here, you can use CSV, SAV, meaning SPSS data files, Excel files, or simple text files also. So let's open an SPSS data file for our analysis. And so then you can see the data viewer automatically pops up, which allows you to check your data import with all the variable names at the top. And then you can also check that you imported all relevant rows here. In your data file, you can see that there are 587 entries total. So you could go to the next section here at the bottom if you wanted to check them all. You can also see there's some missing data in this file here, which is also fine for the lavaangui, so that doesn't pose any problems here. If you need to change variable names, you can do that in the data viewer by double-clicking on a given variable name, and then you can change the label here. This may be necessary if you have used variable names that are not in line with the conventions in lavaan. For example, if you have symbols in there that lavaan doesn't accept for variable names, then you are able to change those here so that the analysis will work properly. Once everything looks good here, you can close the data viewer, which then takes us to the main window of the lavaangui, where you can see that the variable names have already been imported here at the top. So you can directly pick variables, manifest variables from that set of variables that are provided here at the top, or you can go through the other options. So you could, for example, click on multiple variables to select multiple variables here for the path diagram, or you can directly specify a factor model with multiple indicators, or directly specify a growth model. Or you can go really simple and you can go step by step and create one observed variable, one latent variable, or one constant at a time. So you can see here we have rectangles for observed variables, circles for latent factors or latent variables, and then a triangle is used to indicate a constant of 1, which is used for mean structures and intercepts. And then also we have single-headed arrows for factor loadings and regression paths, and double-headed arrows to include correlations / covariances in our model. And on the right hand side, you can see that there's a whole bunch of shortcuts that can make the specification of your path diagram even faster, even simpler. So let's get started in a simple way so we can see how this program works. So I'm going to drag down an observed variable box here, and then you can see this is called x1. Now I can rename this variable to one that's in my data set, or directly select it here. Of course, this is tedious, so now I'm going to select here KFT verbal as my first indicator, and then click on rename. As you can see, it's much simpler to directly drag down variables from the list here. So the second one that I'm going to use is KFT figural. So that's another indicator of a cognitive abilities test, and then KFT quantitative as a third indicator for that factor. You can see that there are some tools here that allow you to align those properly, which is kind of nice. And then the next thing that we can do is we can then add a latent variable here as a factor by dragging down this factor symbol. And then this is also by default called something here F1. If we don't like that label, we can rename it by right-clicking on that circle and then click on rename, and we can enter a label of our choice, such as, for example, cognitive, for a cognitive factor. And then now we can draw our factor loading arrows by clicking on this draw directed arrows icon here, and then we can very easily include our factor loadings from the factor to the indicators. You can see on the right hand side syntax is already being generated. The measurement model here is right now cognitive, is measured by KFT verbal, KFT figural, and KFT quantitative, and that's the lavaan syntax that you would write in lavaan if you use that package within the R environment. So you can copy and paste the commands that you have here on the right hand side. You could paste them into your R or R Studio if you were using that, and then if you have lavaan installed, then you could rerun your model using that syntax. So this is a great way to learn lavaan syntax and to also generate lavaan syntax to have a documentation of what you were actually specifying. Now you can see this was kind of tedious, kind of a tedious way to specify this factor model. Now for the second factor, I'm going to use an option that is a little bit more practical, and that is dragging down the factor symbol here. If I drag that down, then I can directly select variables for the second factor. In this case, I'm going to use the math 1, math 2, and math 3 subscales of a math test. And I'm going to click this here, and then you can see the second factor then is automatically generated, and I don't have to drag down a symbol for the factor or those arrows here. I don't have to put them in manually. But I can still right-click on that factor to rename this factor as math instead of F2. That's a little bit nicer. And then you can see on the right-hand side in the syntax, in the measurement model, now math is the second factor, which is measured by math 1, math 2, and math 3. So the lavaangui automatically adds the relevant syntax as you build your model. The next thing that we might do is we might say, hey, does the cognitive ability factor allow us to predict the math ability factor? So we can do a structural regression model where we predict the math factor from the cognitive factor. And so we can do this by drawing again a directed arrow now from the cognitive factor to the math factor for a structural model. And then you can see that now the lavaangui has added a structural regression here. Math is regressed on cognitive by means of this arrow here. If you didn't have this arrow, so let's take it out again. So we can delete paths by clicking on this arrow so that it's highlighted, and then hitting the backspace key on the keyboard, then it disappears again. So if you ever need to get rid of a path, let's say, oh, you figured out, no, I actually wanted the path to go from math to cognitive, then you can just delete it that way, and then you can put in the correct path. As you can see here, now it goes from math to cognitive. Now, if you didn't have this path at all, so let's take it out again for a second, then this would simply be a confirmatory factor analysis model. So automatically then lavaan would estimate a model that has two correlated factors. And the way you can see that is by going to auto-completed model at the bottom. So switching from the user model, which we're looking at right now, to the auto-completed model shows you that the default settings here are that the two factors are correlated. So that's a confirmatory factor analysis model with correlated factors where also each factor has a variance estimate, as you can see from those double-headed arrows that point to the same factor here for both cognitive and math. So we have a model where the factor variances are estimated, the factor covariance is estimated, and the error variances are also estimated for all indicators. Furthermore, you can see that another feature of this auto-completion or default is that the first factor loading is fixed at 1 by default, and that's because we need to make sure the model is identified, and that can either be done by fixing a factor loading or by fixing the factor variances. Here the choice is by default that the factor variances are freely estimated and the factor loadings for the first indicator are fixed to 1. Now, if you don't want that, you can go back to your user model, and if you'd rather estimate a structural regression model, then again we can put in our structural regression path from cognitive to math, and then it changes the model to have a structural regression instead of that covariance path between the factors. Now, statistically, that doesn't make a difference in this case, whether you have a regression path from cognitive to math or a covariance. This model will generate the same model fit. However, it may make a difference for your purposes, for what you want to do with the model. If we go back to auto-completed model, we can see that now there's not a covariance anymore in the model, but rather there's this regression path. Other than that, we're still estimating the factor variance of the cognitive factor, and we will be estimating the residual variance of the math factor, because the math factor is now an endogenous variable in this model. And you can see factor loadings are still fixed for identification, and also error variances are being estimated in this model. Now, where do you find the results? As soon as you have a model set up, the lavaan will produce parameter estimates and fit statistics for you, and you find the fit statistics by clicking on estimates. So when you go to that estimate icon here, then instead of the syntax, you will find model fit statistics. You can see by default the estimation method is maximum likelihood, because the lavaan assumes that your variables are continuous. That is the default. And for continuous variables, by default, regular standard maximum likelihood estimation is being used. If you don't want that, you can go to estimation, and you can select a different estimator, for example, generalized least squares or weighted least squares. There's also the option of using diagonally weighted least squares estimation for ordinal outcome variables. So if you have ordinal variables that are used as indicators of latent variables, you can define them as such. So let's say if we had a variable math1 that was ordinal and not continuous, we can right click on that variable and then say change to ordered. Ordered means ordinal in the lavaan, and so when we do that, then this variable is seen as an ordinal variable, and then the model is changed to where it uses DWLS estimation, diagonally weighted least squares estimation, which is appropriate for ordinal variables. Now, in our case, that is not necessary, because here we have a model with we have continuous variables, so I can change that back to continuous, and you can see then everything changes back. So it's very nice that this lavaan is very interactive. So as soon as you change something, your output gets changed, and you don't have to start all over with the new specifications. You can see that this model here, estimated with maximum likelihood, yields a chi-square test statistic of 10.794 with 8 degrees of freedom, and a p-value for a chi-square from a chi-square distribution of 0.214, meaning this model is not rejected at the 0.05 level. It's not significantly discrepant from the data. So the model can be retained, and you can see other fit statistics also look decent. The comparative fit index CFI and the Tucker-Lewis index TLI both are close to 1. The RMSEA coefficient is 0.03, which is also considered adequate, and the SRMR is also close to 0 at 0.02. So this is a well-fitting model. Now, where do you find the parameter estimates? The parameter estimates are given under more results and or in the path diagram. So you can see that in our path diagram, we already have some estimates displayed here, such as the regression coefficient for the structural regression, the factor loadings, the variances of the factors, and the error variances as well. Now here you can see currently what is displayed here are the unstandardized parameter estimates. You can see that from the fact that here are some factor loadings that are above 1, and so we shouldn't have factor loadings above 1 in a standardized solution unless we have a special type of model. But in typical models like that, those loadings shouldn't be above 1, otherwise we would have an improper solution. So this shows you this is the unstandardized solution. Also, you can see that from the fact that factor variances are estimated, which in the standardized solution wouldn't be estimated. They would be 1. So how do you get to the standardized solution in the path diagram? You can display that by going to View and then going to Standardized Estimates. So when we click on that, you can see now the factor loadings are standardized here, and the error, everything is standardized here, including the structural regression path. You can see that the lavaangui currently does not display the first loading in the standardized solution, even though that would also be estimated when we have standardized parameter estimates. But we can later on find those standardized loadings for KFT verb and math 1 in the results section that is given here at the bottom. So you can display the standardized solution, and then also you could display other things such as confidence intervals. You could display estimates and p-values, meaning stars displaying statistical significance, or you could display estimates along with their standard errors here in the diagram. Now, more output is provided when you go to more results. Then you can see different window pops up where we find all the estimates along with their standard errors and z-test statistics, p-values, and confidence intervals. By default, the unstandardized estimates are given, and so first are the loadings here. For our 6 indicators in the first 6 rows, we have the loadings with their standard errors and their z-statistics and p-values, as well as confidence intervals at the end. Next here you can see is the math factor with cognitive path. So that's the structural regression path. In the unstandardized form, it's 0.2157. So that's the structural regression coefficient. And then next are the factor variances as well as the residual variances that are provided here. If you want to see the standardized solution, you can click on standardized here, and then all the parameter estimates are given in standardized metric, including also the first loading for each factor, which was in the diagram was not shown in the standardized solution. You can change the confidence level for confidence intervals here on the left hand side. So for example, if you want to have a 99% confidence interval, you can increase that here to 0.99, and then the confidence intervals are automatically adjusted. You can also select fewer decimals, for example, or more decimals. If you want to change those here, you can do that on the left hand side as well. Furthermore, you can display factor scores for those variables that were used in the factor model. So you can see here there are 2 columns with the estimated factor scores. You can switch between or select different methods for factor score estimation here on the left hand side. And you can display modification indices, where you can see which parameter estimate may improve the model fit if you added parameters to the model. In this case, it's not necessary because this is a very well-fitting model. You also get model residuals that can be used to diagnose model misfit also. So that shows you which variance or covariance in your data was not well explained by the model. And you can select different chi-square statistics for overall model fit. For example, when you have non-normal data, you might want to pick a robust chi-square test statistic rather than the regular maximum likelihood test statistic that is used by default. You can select that from the list here. For example, we could pick the Satora-Bentler scaled chi-square from that list, which is robust to non-normality, and then we get this Satora-Bentler chi-square statistic in addition to the standard maximum likelihood test statistic. You can see in this case it doesn't make a big difference. The test statistics are almost the same and the p-values are also almost the same, 0.21 versus 0.229. So in this case there would be no different conclusion here whether we use the regular chi-square or the Satora-Bentler scaled chi-square. Wall tests can also be included if you had certain parameter constraints, but for that we would need to label the parameters so that we can add those constraints, and then they could be tested with this wall test here for parameter constraints. Now going back to our output window here, there are a few more things that I want to point out. One is that you can automatically adjust the layout of your factors by going to apply layout. So from this option you can pick, for example, tree, which then changes your factor model in this way, or you could pick tree 2 if you wanted a different layout. So there are different layouts that automatically align your variables in a way that they are centered in some way and look nice. So that's useful. Let's see what else we have here. There are some experimental ones that maybe you don't want that one. That looks a little bit confusing, but it's kind of nice that they have different layout options here that can be automatically selected. And then also there are grid options, so you can show a grid so that you can more easily align your observed or latent variables when you draw your path diagram manually. So that is also something that can be helpful. I hope you found this video useful to learn about how to generate a structural equation model or factor model using the lavaangui. If you want to learn more about how lavaan works and how to specify models in lavaan, I offer a free workshop for QuantFish that you find in the description, where you can learn how to use lavaan in the RStudio environment. So check that out as well, and I'll see you in the next video.